All right, this example has to do with the composition of two functions, advanced. Now, here we're given two functions, g of x and h of x. Remember, this doesn't mean g times x. It's a function notation. So you'll notice that I refer to that differently than g times x. And here this is telling me, this little circle is telling me to compose g with h. And they also want me to find the domain of g composed with h. Okay. Now, so what I'm going to do, I'm going to first of all start with the composition part. Now, I always like to rewrite this g composed with h of x as g of h of x here with h of x inside of the g function, because that's essentially what you're doing with composition. You're going to take x, plug it into h of x, and take h of x and plug it into g of x. Okay? So it's kind of like taking a dollar bill, plugging it into the change machine, taking your change and plugging it into, the gumball machine. Okay? So you're taking something, plugging into one thing, and taking that result and plugging it into something else. And that's composition. Okay? So this just helps me to focus which function is inside of the other. So to do this, I always take this h of x, which is the inside function. Okay, that's what I'm going to plug in. And I'm going to replace this h of x here with what h of x equals, which is the square root of 4 minus x. Doing this step always helps me to keep organized, so I suggest you do it as well. Okay? Now I'm going to take this square root of 4 minus x and plug it into my g function. Now my g function is the absolute value of x plus 3. So what I'm going to do is I'm going to put the x part, I'm going to make kind of big because I'm replacing x. Right? In this function g of x, I'm replacing x with the square root of 4 minus x. So here's the absolute value of x in this case, plus 3. But I'm replacing x with this value here, so I'm going to put that in here. Okay. Now, when I look at this, I need to look at this and see if I can simplify. Now, I notice that the absolute value here is really kind of redundant because whenever I take the square root of something, that value has to be 0 or bigger. Okay? Which means it's going to be positive anyway. So I'm just going to simplify this by getting rid of that absolute value function. And that's really all I can do. I can't add the 4 and the 3 together because one's inside of the square root and one's outside of the square root. So this is my composition function. Now when you're dealing with square roots and fractions, stuff like that, you're going to have restrictions to your domain. Your domain represents your input values. So what you're going to need to do to find the domain of g composited with h is the first thing you want to do is think about what you're doing here. Remember how I said you're taking x, you're plugging it into, in this case, you're plugging it into h of x first. And then from there, you're plugging that into the g function, so g of h of x. Okay? So the first thing we want to do is we want to look at the domain of h of x. And then the next thing we're going to do is this is going to be a little bit longer process, is we're going to find the domain of g of h of x. And to do that, we've got to do that in 2 steps. The first thing you do is you find the domain of g of x. Oops, excuse me. Okay. So this one, the first thing we do is find the domain of g of x. And then we have to, from there, we're going to have to find the domain of the g of h of x. Okay? So let's look at this example. Let's first of all look at the domain of h of x. So if h of x is equal to the square root of 4 minus x, I'm going to kind of separate those. So here we're finding the domain of h of x. Okay, so what are our restrictions here? Well, if this is, we have the square root here, so we know that 4 minus x has to be greater than or equal to 0. Okay, you can't have any value inside of here that would make this value a negative because it would be undefined. So that 4 minus x has to be greater than or equal to 0 in order to plug it in to that function. So we're going to have to solve this. We're going to subtract 4 from both sides, and then we're going to multiply both sides by -1. Or if you want, think of it as dividing both sides by -1. It all works out to be the same thing. Remember, when you multiply or divide by a negative, the direction of the inequality switches. So this becomes x is less than or equal to 4. Okay, so on the number line, we're just going to do a quick sketch here. That means we have a filled-in circle at 4, and it's going to be less than that. So that's what we have so far for our restriction given the domain of h of x. That's our first half. The second condition we need to meet is to find the domain of g of h of x. So the first thing you do is you look at this outside function g. Are there any restrictions on g? So let's start off by looking at g of x. And g of x is the absolute value of x plus 3. Okay? Now, x could be anything, positive, negatives, fractions. There's no restriction. So basically we're saying it's any real number. And this is a symbol we use to represent that, which basically means there's no restrictions. Once you get to that no restriction part, we don't need to go on to the second step here and to find g of h of x. Okay? So this problem is done. The only other thing we need to do is put it in interval notation. Now, interval notation is basically telling us, it looks like it's going to have, you're going to be using parentheses and brackets. So a parenthesis coming this direction means this is this is your boundary coming from the left side, and this is my boundary coming from my left side. Open bracket means that is not part of the solution, it's just a boundary. This square bracket, so parentheses, is not part of the solution, it's just a boundary. This bracket means that point is also part of your solution. Okay? Now you're going to have a left value and a right value, and they could be a combination of brackets and parentheses. Okay? So what we're going to do here is anytime there's no restriction, then we use either negative infinity, that's the negative, this is the infinity sign, and then no restriction to the right value would be a positive infinity. And when we have no restriction, we don't have those as being boundaries. Okay? So this would be something that has no restrictions. You're going from negative infinity to positive infinity. Your solution could be anything. Okay? So in the example here, I always start going from the left. I have no restriction from the left. So my left value is going to be a negative infinity. Okay? And then my right value is a 4. And 4 is actually part of the solution, so I need a bracket. And this is how you would write the domain of g of h. Okay? That's going to be equal to the negative infinity with the parenthesis to 4 with the bracket. Now let me give you a more complicated example that's going to have a restriction here for our second condition. Now these tend to be some tough problems, so let's go ahead and go through this. First of all, we're going to find f composited with g of x. Go through this one a little bit faster than the last one. So I'm going to change that to f of g of x. I'm going to replace that inside function g of x with the value here on the right, which is x plus 2, because that's what g of x equals. Now I'm going to replace my f function, right? I'm going to basically take my f function here, and instead of x, I'm going to put x plus 2. Everywhere I have an x, I'm going to put an x plus 2. So this is going to be the square root of, instead of x, I put x plus 2 plus 5. Now you can see you can simplify the 2 and 5, right? The parentheses aren't denoting any kind of operation, so I can get rid of them if I want. So this is just going to be the square root of x plus 7. Okay? And that's what f composited with g of x equals. That's the composition function. So now we get to the really difficult part, and we want to find the domain of f composited with g. So if we're going from x, we're plugging in x into the g of x function, and then we're plugging that into the f function. So our final destination, or our final goal, is to find the domain of f composited with g. Okay, so our first part is to find the domain of g of x. And then remember what I said, then we find the domain of f of x, and then we're going to use that to help us to find the domain of f of g of x. Okay, now to do that, we're basically going to find any restricted value we have here and replace that x with the g of x. I'll show you what I mean by that. It's going to make more sense as you see that example. Okay, so I'm kind of dividing this into two little parts here. So let's find the domain of g of x. So g of x is x plus 2. Oops, I went. All right, so here there is no restriction. Okay, and that's fine. But in this case, okay, so there's any real numbers. We still need to go on to this next part. Okay? Now, the domain of f of x, okay, this is going to be let me look at f of x, sorry. Sorry, I just got thrown off a little bit. I meant to do a different example first, but this is okay. This will, you can see here that the domain of f of x, when you're looking at the square root of x plus 5, that x plus 5 is inside the square root. We know that has to be greater than or equal to 0. And then we're going to subtract 5 from both sides. Okay. Now here, from here, we're going to need to plug this in and replace this x here with g of x. Okay? That's going to be this step here. So replacing x here with what g of x equals. And g of x equals x plus 2. So I want you to look at this again. I'm replacing this x value here with g of x. So maybe I should give you this and then g of x is the same thing as x plus 2. So I'm replacing that with x plus 2. Okay? Now you're going to solve it. So we subtract 2 from both sides, and we have x is greater than a negative 7. Okay? So we have our little number line. Here's a negative 7. It's greater than or equal to, so we have a filled in circle, and it's shaded to the right because it's greater than. So in interval notation, we're going to, our left boundary is a negative 7, and it's part of the solution, so we put a bracket. On our right boundary, there's no restriction, so that's infinity, and we put a parenthesis there to show that that's not a boundary. Okay, so just to recap here, you always have to do, when you're finding the domain of these, you've got to consider two cases. This was my first case. You find the domain of g of x. And then we work on finding the domain of f of g of x. You have to do that in two parts. The first thing you do is you find this domain of this outside function, f of x. And then you're going to substitute or replace x with g of x so you can find the actual domain of f composited with g of x. Okay, so here's the finding the domain of x. X plus 5 is greater than or equals 0. We solve that for x. Then you replace x with g of x, the inside part of the function. Substitute its value, x plus 2, in place of that g of x, and solve again. And that is going to give you your domain. So basically, remember, we're finding the values of x such that we can plug it into g of x and then plug that result into the f of g of x. Okay? That's this part of our solution. Now, on this one we did the same thing, but we stopped here during our second case because once you get all real numbers here, then we knew we were finished with this part. Okay, so let me give you the most complicated one that's gonna not have any restrictions on the domain of h of x or the domain of the composition function. Okay, so that's when we get something like this where we have two square root functions. Okay, so composition of f composited with g of x. I'm going to rewrite that as f of g of x, put the g of x on the inside there. Replace the g of x with its value here, which is the square root of a negative 1 minus x. Okay, and then we're going to go back to our f function, and that's the square root of 5 minus something. So I'm going to put the square root here of 5 minus, and if you want, you can put parentheses and then simplify it. And then, because that helps me to remember that what I'm putting in parentheses is what I'm replacing this x with. Oops, sorry. This x. Okay, so this x I'm replacing, okay, see this x here? This x here? I replace this x here with this. So I'm going to do the same thing on this side. Replace this x with this as well. So a negative 1 minus x. Okay, there's nothing to simplify here. My answer is just going to be the square root of 5 minus the square root of a negative 1 minus x. That parentheses on the inside didn't serve any purpose, so I went ahead and simplified it. And that's f composited with g of x. Can't do anything else to simplify it. That's as far as you can simplify it. Okay, so now here we go to the little more complicated part. So remember, we were starting with x. We plugged that into the g function, g of x, and we're going to then plug that into the f of function, so f of g of x. So we have two conditions we need to meet. We need to find the domain of this and the domain of this one. Okay, so domain, divide this into our two parts. Usually that second part's going to need a little more room than the first part, because remember, to do this one, we need to first look at f of x, and then plug that into the f of g of x. So we find the domain of f of x, and then replace let me just grab that. Replace the x with the g of x. That's what we did. So we're going to need to do that in two steps. So let's do this one over here first. So the domain of g of x is equal to the square root of a negative 1 minus x. So that means all the stuff inside of the square root, negative 1 minus x, has to be greater than or equal to 0. Okay? Those are the only x values that we can use to plug this into here and get a y value back. Okay, so I'm going to add 1 to both sides and divide both sides by a negative 1. And I get x is less than or equal to negative 1. Okay? And then I'm going to come over here to the f of x function, start off with that. F of x is equal to the square root of 5 minus x. So we know the restriction to that is that 5 minus x has to be greater than or equal to 0. Okay, so we're going to subtract 5 from both sides, and then divide both sides by a negative 1, so it switches the direction of the inequality. So x is less than or equal to 5. Now we're not done here. This is where it's going to be tempting to kind of stop. But remember, we've got to replace this x with g of x. So g of x has to be less than or equal to 5. Well, we're going to replace g of x with its value here, which is the square root of a negative 1 minus x. Okay. Now here, to undo this, you're going to need to square both sides. I don't have a whole lot of room, so I'm going to show what I'm doing here by changing that color there. So square both sides. And when I do that, squaring something that's square rooted, they undo each other. That's why I did it. So I get a negative 1 minus x is greater than or equal to 25. Now I'm going to add 1 to both sides and divide by a negative 1. So x is greater than or equal to a negative 26. So now what I need to do is take these two values here, kind of put them on the number line, and see what I have for my solution. Okay, so I'm just going to put a 0 here, and a negative 1 here, and a negative 26 all the way down here. And this one, x is greater than or equal to negative 26. The equal to part means I have a filled in circle. Greater than is going to be to the right. And for this one, x is less than or equal to a negative 1, so the equal to part makes it a filled-in circle, and less than means it's going to go to the left. Now, that means my solution is in between these two values here. So when I'm doing my interval notation, I'm going from negative 20, start from the left, negative 26, and that is part of my solution, so I put in a bracket. And then I'm going to go all the way to a negative 1. And that is part of the solution, so I put it in a bracket. And that's a negative 26 to a negative 1.